So that will be option D. Next topic here is air. The usual gaseous constituents are nitrogen, oxygen, water vapor, carbon dioxide, and the noble gases, which majorly you have argon and neon. Proportion of oxygen in the air, e.g., we have way by which they can be absorbed because of their affinity for such substance. Let's talk about evidence that air is a mixture. The evidence that air is a mixture is as a result of the what? The constituents of air can be separated easily by physical methods. Then under the composition of air, where we have carbon dioxide. Carbon dioxide has affinity for caustic soda, which is sodium hydroxide, and lime water. So if you have a mixture containing a mixture constituent of air containing carbon dioxide, for example, if we are to remove this carbon dioxide from air, we need to pass it through caustic soda or by use of lime water, where you have it, if it combines with lime water, CO2 plus lime water, and that is another test for what? Carbon dioxide. So you have the formation of CaCO3, that's calcium triisocarbonate 4, and water will be the byproduct in that regard. So one way of testing for carbon dioxide is to pass it through lime water because of the fact that carbon dioxide has affinity for lime water. So when it comes in contact with lime water will absorb the carbon dioxide, and calcium triisocarbonate 4 and water will be formed as a byproduct. Then also oxygen. How can oxygen be absorbed or be removed from air? It is by use of what? Alkaline pyrogalore. So that we use alkaline pyrogalore or burning phosphorus. Alkaline pyrogalore is an organic compound. It's a derivative of benzene. Benzene has, this is the structure of benzene, where you have one H here, another 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 H here. This is the structure of benzene. But where you have the 3 hydrogen atoms here being replaced by a OH group, that's hydroxyl group, then you can call it alkaline pyrogalore. That is, what am I saying? If you have a compound like this, so where this is now, the H has been removed, has been replaced by OH, the H has been replaced by OH, the H has been replaced by OH, and every other one will be here. And this is what is called what? Alkaline pyrogalore. So the formula is C6H3, then you have OH3. So it has affinity for oxygen. So when oxygen comes in contact with this alkaline pyrogalore, it will absorb the oxygen. Thereby, oxygen can be removed from the constituents of such air. Then, also by using burning phosphorus. So burning phosphorus can combine with oxygen, and an acidic oxide will be formed in the process. What is an acidic oxide? Acidic oxide is an oxide of non-metals. Example, when you have P4O10, which can be broken down to P2O5, and this is what is known as what? Phosphorus 5 oxide. In fact, it's an important drying agent. So definitely when oxygen combine with burning phosphorus, this 4 compound will be formed in the process. That is one. So 2 ways by which oxygen can be removed from the sample of air is by using alkaline pyrogalore or by using what? Burning phosphorus. Then nitrogen. Nitrogen can be removed by fractional liquefaction of what? Liquid air. Then we still move further to talk about the objectives. Air as a mixture and some uses of what? Noble gases. So the noble gases are those gases, they call them noble simply because of their unreactivity. Because they are either in the duplet state or the octet state. An example of noble gases that we have our helium, then we have our neon, we have krypton, Kr, and so on and so forth. You have the xenon and the likes. So what am I trying to say here? These are the collection of the noble gases. They are noble simply because of their unreactivity, because of the fact that the outermost shell is complete. Because every element is working towards what? Stability. You can only be stable either at the duplex state where you have 2 or octet state where you have 8. So at this point, they can no longer react. That is why they are known as noble gases. Then the use of noble gases. Argon is used in gas-filled electric lamp simply because it helps to prevent the oxidation of the lamp filament. Because when there is an oxidation, automatically oxygen has been introduced into such a system, and it will eventually give undesirable products. So instead of getting or obtaining such an undesirable product, that is the essence why we need to prevent that from happening. So argon is used in gas-filled electric lamp so as to prevent the oxidation of the lamp filament. 2. A mixture of krypton and xenon is used in the photographer's flash tube for taking high-speed pictures. If you take high-speed pictures, you take high-speed pictures, you just need to mix krypton with xenon, and you incorporate into photographer's flash tube. Then 3. Neon lights are also used in aerodrome beacons as they have a high power of forge penetration. So you have a mist, and you want to penetrate, you want such to be penetrated, so you can use neon lights because of the fact that it has a high power forge penetration. Then also number 4, helium. Helium, being non-combustible and yet as light as hydrogen, is often used in observation balloons. So instead of using hydrogen, helium is used because of the characteristic of non-combustible or non-combustibility nature, which is the reason it is preferred to hydrogen in observation balloons. Then number 5, radon or radon. Radon is a radioactive element simply because it disintegrates in no distant time and is used in hospitals for cancer therapy, which is treatment of tumor. Then objectives, as far as this topic is concerned, candidates should be able to deduce reasons for the existence of air as a mixture, and the reason for the existence of air as a mixture is simply because the constituent of air can be separated by easily by physical methods. Then also identify the principle involved in separation of air compounds, which we discussed earlier, where I said carbon dioxide can be separated or can be removed by using caustic soda or lime water. Oxygen can be removed by using alkaline pyrogalol or burning phosphorus. And nitrogen can be removed by fractional liquefaction of liquid air. Then also deduce reason for the variation in the composition of air in the environment. The reason for the composition of air, variation in the composition of air, is because of the global climate change, where you have a global warming and greenhouse effects. Then also specify the uses of some of the constituents of air. So we have to specify the use of some constituents of air in the subsequent slides. The uses of some of the constituents of air are enumerated below. Carbon dioxide. It is used in drinks because of its refreshing taste, and that is why in Coca-Cola, by the time you open the cover, it's got a particular gas comes out, and that particular gas is notable, and it is carbon dioxide. So that is one of the uses. Then also water vapor. It helps us to what? Breathe. It helps us to breathe. Then oxygen. Oxygen is required during respiration. Then nitrogen. Nitrogen is used in chemical industries to make fertilizers, nitric acid, etc. Then we have, because of its what? It has a diluent nature. Then smoke and dust particles. That's why it's used as a diluent. Smoke and dust particles. Smoke and dust particles used as flavor agents and preservative for various food stuff. Now let's look at questions that UTME questions that are designed for this particular topic, so that we can appreciate the beauty of what we have learned so far. Then UTME questions as shown below. Question 1. Oxygen in air can be removed by using, so the answer is not far-fetched. A. Lime water. B. Caustic soda solution. C. Alkaline pyrogallop solution. D. Slaked lime. Remember I said it. A. Lime water. You can't use lime